All right, today's lesson is 47 graphing functions. What's our objective? Get ready?
Graphing function.
Very good, graphing functions. I like how Alex is in learning position. Nice job, Alex. Okay, you will understand and identify the domain and range of a function, what a continuous function looks like, a direct proportion function, and we'll also see a step function today. So really there's 4 main vocabulary concepts today. So you're going to learn new names for things we've already done. We've done input and output and talked about function rules. So let's give an example of a function rule, now that it's snowed. For every driveway that I shovel, I earn $10. This is the rule, $10 per driveway shovel. My input would be the number of driveways that I shoveled. So I could shovel 1 driveway, or 2 driveways, or 3 driveways, or 4 driveways. Could I shovel 1 2/3 driveways? Probably I wouldn't get paid if I didn't finish the job. So we would say this rule has to be like a completed job, 1, 2, 3, 4, etc. Could I shovel negative driveways? No. Could I shovel 0 driveways? I guess you'd get $0. So I would say the possible values for my input would be the counting numbers, 1, 2, 3, 4, 5. We have a name for the possible values that you can input into a function. It's called domain. What is it called? Get ready?
Domain.
Domain. It's the possible values for the input of a function. Now the output would be, remember I got $10 per driveway? So I could get $10 or $20 or $30 or $40. So my output would be multiples of 10. Could I have 0 or like negative dollars paid? No, that would never happen. Would I get $15 ever? That would never happen either because we have to complete the job and get a full payment. So my possible values for my output would be 10, 20, 30, 40. So how we write this, let me put it on the next slide. The domain and range look like this. So my inputs are, we're going to use a colon and we're going to use set notation, would be 1, 2, 3, 4, these are the driveways, as many driveways as I could do. My output or range we said was the dollars I get paid. That's the output. The possible values would be $10, $20, $30, etc. So, domain, possible inputs. What is the domain? Get ready?
Possible inputs.
Good, possible inputs. The range are the possible outputs. What is the range? Get ready?
Possible outputs.
Possible outputs. So 2 new vocabulary words, domain and range. Do you know how I remember which is which? It's alphabetic. It's alphabetic. When we talk a table of values, we talk about input, output, domain, range. I comes before O, D comes before R. Same thing. Normally we put X and Y, right? X and Y are also alphabetic. That always helps you remember which one's on the left side, which one's on the right side. So we're going to do next a parking garage scenario where we're going to graph it and talk about input and output, domain and range. So the rule is you pay $1 for the first hour of parking. So first thing I do is park, right? And I park for a certain amount of time. That's the first thing that happens. So that's my input, hours parked. Then after I've parked, then there's a cost. That cost depends on how many hours. So this comes first, the cost comes second. We'll call that C. We call this H. So in this case we go H and C for cost. So if I parked up to 1 hour, the rule is you pay $1. So if I even parked 15 minutes, I pay $1. If I parked a half an hour, I still pay $1, still pay $1, still pay $1. And as soon as I cross 1 minute after that hour, my cost jumps up to this rule, $2 for each additional hour. So now I'm going to jump up. As soon as I park for a little bit more than 1 hour, I'm going to pay $3, all the way up to 2 hours. Now, here I'm not going to have to pay the $3 if I'm still at 1. So the charge for $3 happens just after 1. That's why we use a hollow circle there. Same thing, from 2 to 3, it's going to jump up here to $5. Then I do another hour, it's going to jump up another $2, another $2, another $2, another $2. And there's some rules and restrictions here. It says there's going to be a $15 maximum. So looks like once I get to right here, I don't have to pay any more. It's never going to go any higher. How long can I sit there? How long can I get a $15 charge? There's a time restraint. 6 a.m. to 10 p.m. How many hours? From 6 a.m. to 10 p.m. All right, let's go 6 a.m. to midday or noon, and then we'll go to 10. That's 6 hours. 12 to 10 is 10 hours. 6 plus 10 is 16 hours. So I don't have it on my graph, but at 16 hours, I gotta stop. I'm starting to find the constraints for my domain and my range. Domain. What are my possible? Let's just put it right here. Domain. My possible inputs are time anywhere. An hour, 2 hours, 3 hours, 3.5 hours, 4.25 hours, 6 hours and 2 minutes, up to, we'll put H can be anything positive, but it has to also be less than, we said, 16 hours. But it could equal 16 hours, but it can't go past 16 hours. So here's my possible values for hours. That's my input. Based on my input, what are my possibilities for my output or my range? Well, I paid $1, $3, $5, $7, $9, $11. Did I ever pay $2.50? No. Did I ever pay 75 cents? No, I only paid $1, $3, $5. So my range, I do set notation, $1, $3, $5. And I capped out, I maxed out, because I could draw this out here, at 15. $15 is the max. So this is my possible values for range. Domain and range. So let's quiz you. What do I call the list of possible inputs? Think. Get ready?
Domain.
Domain, very good. What do I call the list of possible outputs? Get ready?
Range.
Range, domain and range. Domain is X, range is Y, your output. Did we answer all the questions? Domain, range, label the axis, did it, graph it, did it. Oh, that was the last thing. It's got a name. Isn't this kind of cool? It's called a step function. Can you see why it's a step function? Are there breaks and gaps in my graph? Is this a break or a gap? Yes. Okay, so it's stepping through. It's not continuous because there's breaks and gaps, which leads us to our next graph. This graph is going to be not a step function. This time they give us an equation to use, and they have us start with a table. So this is for the equation, the perimeter of a square. There's 4 times the side length. So let's talk about some possible values for a side length of a square. How big can the square be? Lucas?
1.
Could be 1 inch or 1 foot. Spencer?
It could be a quarter.
Oh. So maybe like we could do, this is 0.25 of an inch. It could be 0.5 of an inch, 1 inch. It could be like decimal values. Jacob? It could be 4, 2, 3, 4. Could it be negative? Not really. You could have a negative length square, like the side length. Could you have a square that has no length at all? It wouldn't really be a square. Like that dot, if I could get, like a theoretical dot wouldn't really have any size, I guess. You couldn't make a square out of it. So we couldn't really have a 0. So already I'm starting to formulate all the possible values for the side length of a square. My input, this is my input, or domain. This is my output, or range. I'm already figuring out domain is going to be, we said it was positive. S has to be greater than 0, but could be anything. Can't be negative, and it can't be 0, or we wouldn't have a square. Okay, so that's good on domain. My range, well, this says to times 4 times the side length. So 4 times a quarter would be 1, 4 times 0.5 would be 2, 4 times 1 is 4, 4 times 8, 4 times 12, and then 4 times 16. Let's graph those. 0.25 is 1, so we're here. 0.25 is 1, 0.5 is 2, 1 is 4, 2 is 8, 3 is 12, 4 is 16, etc. Look what I have. And we said it could be any value between these points. It just couldn't be 0. This function is a continuous function because there are no breaks or gaps. It's called continuous. What is it called when there's no breaks or gaps? Get ready?
Continuous.
Continuous. It's also the shape of a line or linear. Linear, the root word is line. Okay, so it's linear, it's just straight. And it goes through the origin. So, another vocabulary term. If it's linear, if it goes through the origin, it's called direct proportion. What is it called? Get ready?
Direct proportion.
Direct proportion, so linear. Goes through origin. It is equal to, it has a direct proportion. Sometimes they use the word direct variation, direct proportion. We talked about domain. The possible values here is the domain. We talked about range. We talked about continuous. And we talked about step functions. Give me a thumbs up if you understand every vocabulary word. Okay, very good. Pop quiz. Turn to your neighbor. Tell them what the domain represents. Go.
Input. Isn't it input?
Chelsea, you can turn to Stacia. And Spencer, did you tell somebody?
I don't want to.
Okay, back to me. 3, 2, 1. All right, turn to a different neighbor. Explain to them what the range represents.
The output.
The range represents the output.
Dakota, you tell Hiram. Hiram, tell Dakota.
The output are the points that are getting set on the graphicus.
Okay, very good. Back to me in 3, 2, and 1. Good. Domain was input. Range is output. And we talked about everything else on this lesson. So we are going to go right to the practice set. Page 323. Problems are A, B, C.